Okay, let's take a look at GDC skills, sketching a function. Looking at how we can use the GDC to produce a sketch, so not particularly accurate, but a sketch of the graph, clearly indicating vertices, axis intercepts, so let's take a look at GDC skills, sketching a function, focusing on how we can produce that sketch, clearly showing axis intercepts, vertices, and asymptotes. So the first thing we want to do is actually sketch the function. So on your GDC, if you go to create a new graphing page, go add graphs, and if this doesn't come up, just press tab and it should do. So we're going to enter that function. If you want to get a fraction, you just press Control and divide, or of course you can use brackets to keep everything within the denominator and not bother with the fraction. So if we go 1 over x to the power of 3 minus 3x squared, all minus 2, hit enter, then we've got the shape of our graph. Now we want to produce that sketch, and in order to do a sketch we need those 3 key features that I've indicated here. So the first thing that it might be worth finding out is these asymptotes. Now the asymptotes can be a little bit difficult to get from a GDC. So it helps, yes, you can look at it visually, right? And I'm thinking it could be an asymptote at about y equals 2 for the horizontal. Right? If I make that prediction, I can check it and type in y equals 2. Of course, what I meant was negative 2. And that looks reasonable. But let's double check it. For a horizontal asymptote, we need to think, what can the function not equal? And y, if we look at this bit, that bit cannot equal 0, but there's this minus 2 here. And that indicates a translation of 2 units down. So in this example, we probably could get the function equal to 0. That would occur if this bit equaled 2. 2 minus 2 is 0. What we can't have is this being equal to 0. Therefore, it would not be possible for y to be equal to negative 2. And that's what we see on the GDC in that red graph that I drew. So that's the first thing that we can draw in, a horizontal asymptote at y equals negative 2. I'm not actually going to be sketching the curve until I've got all of these key features. The next thing is the vertical asymptote, or totes. In this graph, we can see that there are 2. Again, we can get a bit of a visual. But the best way of doing this is algebraically. Where we know that the denominator cannot equal 0. We cannot end up with 1 divided by 0. That comes back to the idea of conditions that result in a domain restriction. So all we have to do is set that denominator equal to 0. Factorize out x squared and apply the null factor law. Yes, it was a cubic, but the null factor law still applies. If a times b is 0, then a or b must equal 0. So we have 2 scenarios here, and that means that we could have vertical asymptotes at x equals 0 or x equals 3. Let's double check that on the GDC before we actually mark it onto the graph. If we go to menu and graph entry edit and change it to a relation, then we can type in x equals 0. Press tab and we can type in another one, x equals 3. And yeah, that actually looks like it is correct. So we can mark in these vertical asymptotes at x equals 0, so the y-axis, and remember it's a sketch, so accuracy isn't so vital, and at x equals 3. So we've got our asymptotes sorted. Next is the vertices, and there is a way to find the vertex for this, but it involves calculus. Using your GDC, that's quite easy. You've got two options. You can go Menu, Analyze Graph, and then choose Minimum or Maximum. But I think it's always easier to go Analyze Graph, Graph Trace. Because what that allows you to do, you can switch between graphs using up and down if it's not on the right one, but we want this blue curve here. As you move along, graph trace will stop at key features such as y-intercepts, x-intercepts, and vertices. And you can see that it's stopped here at negative 2.25. So we have a vertex. Let's just do roughly 1, 2, 3 at 2. If that's negative 2, negative 2.25 is going to be there. Okay, so we have a vertex at 2, negative 2.25. Alright, the next thing is any intercepts. Alright, and we can see that there's an intercept here. So if we keep scrolling across, stops on the 0 at 3.05 approximately. Okay, don't be put off by this negative and the 4 at the end there. For some reason, the GDC often will do that. So we have all the key features now in order to sketch this. There's only one way that we can actually make this work. Alright, if we have an x-intercept here, you might be wondering, well, how do I know how the graph goes? Well, the only way that that can work is for it to go like that. Any other way of drawing that and it will cross the asymptote, which we know that it can't do. So you might be wondering, well, why is it not that? Well, if it's that, it crosses that horizontal asymptote. Alright, so the only way for that to work is like that. This middle section, alright, well, we know it's got to go like that because of the asymptotes. And from our GDC, we can see that this bit is here and not up here. If you're really unsure, then you might want to take a value below 0 and substitute it into the function. And what you would find is that it can only ever be negative.